Hi guys and welcome to .NET Mastery. My name is Brogan and in this course we will explore the basic foundation of .NET Core web applications with Razor Pages. We will be using .NET 6 and Visual Studio 2022 for this short course. .NET Core has been a buzzword for a while and most of the new development in .NET is built on .NET Core and the current version is .NET 6. .NET Core comes with great features and advantages as compared to the previous versions of .NET. But for starters, let's take a brief overview at topics we will cover in this course. Whenever we learn any programming language, the first thing is basic foundation. So we will start with the fundamentals of ASP.NET Core application. Then we will take a look at what is new or what are the changes in .NET 6 as compared to the previous version. Once we have a solid foundation in .NET Core files and folder structure, then we will take a look at Entity Framework Core. That is what we will be using to interact or create our database project. Using Entity Framework Core and .NET Core, we will perform CRUD operations on a particular model. When we do that, we will understand the client-side and server-side validations in .NET Core, and we will display alerts using TempData. That will give you a good foundation in .NET Core. But the main thing that I will also include is error solving. I will display you common errors and how to resolve them. That way you will gain more confidence in what you will learn. Lastly, the application that we will build, we will deploy that to Azure along with the SQL Server. So with all of that, you will have a good starting foundation in .NET Core using Razor Pages. In this video, let's take a look at what we will build in this course. From the URL here, you can see that the application is live on Azure. We will host our application on Azure along with SQL Server. Then in the top navigation, we have a home page and a categories page. If you click on categories, we do not have any categories right now. So we can first click on Create a Category button. And on this page, if you click the Create button without populating any fields, we get error messages. These are client-side validations right out of the box. We also have a button to go back to the list. Then if we go back on Create page and if we populate the details in the category, with just the name, we still have validation with display order. We also have a custom validation that if name and display order are same, then we will also display a custom error message. The error that you see this time is a server-side validation. Then if we have values that passes all the validation, and if we hit the Create button, we have nice alert to display the confirmation. We will be using Toastr.js for these alerts. Then we have all the categories that we will be displaying in the table here. We can edit them, and once we update them, we again have our alerts confirmation. Lastly, we also have the delete functionality with the alerts. And then for the theme that we are using for styling, we are using Bootswatch theme, and we will deploy our application to Azure. So you can see there are quite a few things to learn in this small project. Let's get started with all of them from the next video. Let's take a look at all the tools that we will use in this course. We will be using .NET 6 for our application. So make sure to install the latest version of .NET 6. For the IDE, we will be using Visual Studio. The version that I will be using is Visual Studio 2022. There are lots of advanced features in 2022 as compared to 2019. So you can always install the free version of Visual Studio 2022. For our database, we will be using SQL Server. So first you will have to install SQL Server and then you should install SSMS, which is SQL Server Management Studio. If you have older version of SSMS, that's completely okay. As long as you're able to connect to SQL Server on your local machine, we will be using that connection string and everything will work. So once you install all three of these softwares, let's continue from the next video. In this video, I want to walk you through the journey of .NET Core. .NET Core is probably the biggest change that the .NET language has encountered. In 2002, Microsoft introduced web forms, which was a revolution at that time. Web forms has its drawbacks, and there was a need to overcome all of them. Because of that, the .NET team came up with a new architecture, which was .NET MVC. Now, even though I love MVC and I have built many applications in MVC, it had its flaws, like it was created on top of the components for web forms. Because of that, it was tied to IIS and ultimately Windows operating system. But with the evolution of web development, Microsoft had to keep up with the changing technology. Finally, in June of 2016, Microsoft released ASP.NET Core, and it was the first version. Now, .NET Core is built on top of the new .NET Core framework. It is completely rewritten, and it is a cross-platform version, hence it is not tied with Windows. Also, .NET Core was built with cloud in mind, so it is extremely robust with that. Then in August of 2018, Microsoft released .NET Core 2, and the team has been active with releasing new versions. There was a big change from .NET 2.1 to 2.2 because we had to update quite a few class libraries and there were few challenges. But since then, .NET Core team has been releasing new versions with 3, 3.1, and .NET 5, which was released in November of 2020. After that, there is .NET 6, which will be released in November of 2021. We will be using the preview version, but whatever we learn will be the same once .NET 6 is released. So this is a small overview of all the .NET frameworks and their evolution. That being said, why should one use .NET Core as compared to the classic .NET? .NET Core comes with many advantages. First one is ASP.NET Core is fast and open source. If you compare that to the traditional .NET applications, there have been quite a few benchmarks, and it is very fast when you compare that to web forms or even .NET MVC. .NET Core is also cross-platform. The classic .NET was tied to IIS and Windows, but since the .NET Core is rewritten, it has removed that dependency with .NET Core. We also have a built-in support for dependency injection, which saves a lot of time and it is extremely helpful. Once you get used with using dependency injection, you cannot imagine your application without that. With any programming language, it is critical that the new updates or the new version that are released, they should be easily upgradable. And that is one of the features with .NET Core. When a new version is released, updating to that new version does not have groundbreaking changes. Because of that, you can always keep up with the new versions. .NET Core is also cloud-friendly. When the .NET Core was being written, cloud architecture was kept in mind, and because of that, it is completely compatible with all of the cloud components. And lastly, when it comes to performance, .NET Core exceeds all of the previous versions, and even the new versions in .NET Core that are being released, they supersede the previous version. The code actually gets more optimized that results into improved performance. The ASP.NET Core compiler will eventually optimize the entire code whenever the code is recomposed using the .NET Core framework. .NET Core's actual performance is multiple times than any of the framework's previous implementation. Because of that, it is clear that Microsoft has a long-term plan with .NET Core technology. So with that brief overview, let's continue our learning in the next video. In this video, before we take a look at the other files, I will introduce you to a new concept, which is dependency injection. ASP.NET Core implements a simple built-in dependency injection. Container dependency injection is an integral part of the ASP.NET Core architecture. .NET Core injects objects of dependency classes through constructor by using the built-in IOC container. Before I show you what advantages dependency injection brings, let's see a scenario where there is no dependency injection. In a typical application, let's say we have 3 pages right now, and we have some common functionality that we want to use across all the 3 pages. Like let's say we want to send emails and we want to access our database in all the 3 pages that we have. Now let's imagine that on these 3 pages we need to access the database first. So what we will do is we will create the object for database classes on all the 3 pages. We will have to open that connection, we will have to do the database operation, and then we will have to close the connection in all the places. To do the same and create object for email implementation that we have in all the 3 pages. So you can see this is a lot of duplicate code. On top of that, what happens in future if you change the implementation of how you access the database or email? Based on the current configuration, you might have to make that change in all of the 3 pages, which is a big mess because right now it's 3 pages. Down the line, it could be 30 or 300 pages. Another issue here is that on each page, you will deal with creating the object, managing them, as well as disposing them. And that will be a time-consuming effort when we have to do that in all the pages. So that being said, what is a solution to avoid all of this and get an optimal architecture? The answer to all of that is dependency injection. First, let me show how this scenario would look like. Again, we will have the 3 pages, and we will have email and database functionality. These are the common things that we had before as well. But now we will have something special, which is dependency injection container. So as you can see, we have got our dependency injection container that will have an iEmail and an IDB interface and its implementation. So inside our container, we have the implementation of the iEmail interface and the IDB interface. When any page will need access to these functionalities, it will just ask the dependency injection container to create an object of this functionality and directly give page an object to use. So inside the page, we will actually be using an interface, and then dependency injection does all its magic of passing the object when the website needs it. That way, we do not have to deal with creating the object, disposing, or managing that object inside our pages. Our pages will look very clean with just the interface. All the instance and implementation will be done by dependency injection container. Now in future, if you want to change or replace the email class, you do not have to make any changes in the pages. All you have to do is just change the implementation inside the email class, and since we are registering that in the container, next time when we build the project, it will take the new implementation. So you can see we only have to change in one place now. That is one of the main advantage that comes with dependency injection. Now in order to use dependency injection, you can use many third-party tools. But with .NET Core, we have a built-in dependency injection container, and that has its own advantages. So I hope with that you have a short overview of how dependency injection is helpful. First thing that we have to do is we need to create a new project. So I have opened up Visual Studio 2022, which will be the editor for this course. Here on the left hand side, I have my previous projects, and on the right hand side, we have the options to get started. We will click on Create a New Project, and we have lots of templates that are available. We want to create a web application, so we can select that, and we want the web app with Razor pages. So that is the first option that is being selected. But if the first option in your case is something different, scroll down and look for ASP.NET Core Web App. It should only be Web App and not the web app with Models View and Controller that you see down here. We are working with only Razor Page application. So select that and we will hit the next button. Next thing that we can give our project is a meaningful name. We will call that as Abby. Now here you notice there is a project name and a solution name. A solution can have multiple projects. Let's say we are working on Abby Web Project. So we can call that Abby Web, and then we can just change the solution to be Abby. So all the projects that are related to Abby will be inside this same solution. Next, let me change the location to where I want to save the project, and we will hit the next button. Here we will get some more options on what is the .NET framework that we want to use. I will select .NET6 here, and next we have the authentication type. Now if we want, we can select the pre-built templates that are available with authentication. But we want to start from scratch, we will select none here. I do not want any Docker, and then we have enabled Razor Runtime Compilation. This is a great package. Because of that, when your application is running, and if you change something in the view directly or the UI side, you can refresh the application and see the change as compared to rebuilding the application. So we will enable that, and let's hit the Create button. That will create our project, and we will see all the files and folder structures on the left-hand side inside the window of Solution Explorer in Visual Studio. Now by chance, if you close the window, do not panic. You can reload that by going to Views, and the first one here is Solution Explorer. So now that our project is created, let's continue in the next video. In this video, I want to give you a brief overview of Razor Pages. Razor Pages have been introduced in ASP.NET Core from the version 2.0. Razor Pages is a new feature of ASP.NET Core that makes coding page-focused scenarios easier and more productive. In MVC, we have models, views, and controllers, but inside Razor Pages, we have page and page model. So everything for that page is isolated and condensed in one single location. That being said, Razor Pages is not just for simple scenarios. Everything that you can do with MVC, you can do by using Razor Pages like routing, models, action result, tag helpers, and so on. That is just a brief overview about Razor Pages, but we will explore everything with Razor Pages in the future videos. Now that our application has been created, let's take a look at the first file, which will be the project file. Project file, you won't be able to see that directly inside the files here. You will have to right-click, and we have Edit Project File. When we click here, you will see few options that are configured. The first one here is the property group, and that denotes what is the .NET framework that we are using. We are using .NET 6 here, and it is displayed there. Next, what we have is the item group. Item group will have all of the NuGet packages that we will be adding in our course. Right now, we just added the Razor Runtime Compilation when we created the project. But in future, we will be adding more packages for using SQL Server, Entity Framework Core, and much more. Once we add that, a new entry will be made inside the item group. So that looks good for our project file. With that, let's continue in the next video. The next file that we want to take a look is inside the properties folder. We have launchsettings.json. This is the file that configures how the application will be run, and you can see there are multiple profiles that are added by default. We have an IIS settings on the top, which says that if you are using IIS Express to run the application, Your application URL will be this, and the SSL port will be 44317. If we expand the profiles here, we have two profiles, AppyWeb and IIS Express. These are the same profiles that you can see if you hover on the down arrow icon right here. We have AppyWeb and IIS Express. In order to run the website, we can just hit this play button after selecting the profile. If we select IIS Express here and run our website, it will launch the default application inside the window directly with the 44317 port number. Great, you can see that is working. Now if we stop this and change our profile to AppyWeb, let's expand that. You can see here it is command name, which is project, .NET Run Messages, and we have application URL. So this will run our application from command prompt. And from that command prompt, it launches the browser. This time it is running on port 5001. So these are two different ways of running the .NET Core application. Inside the profiles, we can have environment variable and other configuration. These are just two ways to run your application, and we can modify them inside the launch settings.json. The next thing that we have here is www root folder, and in there we have CSS, JS, and lib folders. www root folder will be the root directory of your application. That will be the directory that contains all of your static files. So if you have CSS, JavaScript, images, PDF, files, libraries, all of them will go inside the www root folder. Inside this www root folder, there will not be any code behind file with the C# code. It will only have static files that will be used from the pages. So make sure whenever you add any static files, it will go inside this www root folder. Next, what we have here is the pages folder, and that contains all the coding pages that are there in the application. We will come back to that in the upcoming video, but the last file that I want to discuss in this video is the appsettings.json file. Now what happens is in an application, you are using many third-party APIs, and then you have to store some secrets. You can also have connection strings that connects to the database and so on. So all of those secret keys or connection that you have, you will add them inside this appsettings.json file. As the name suggests, it is a JSON file which will have key value pairs. If you expand this, you will notice there is appsettings.development.json. So you can have different app settings for different environment. For production, you will have appsettings.production.json and so on. Then based on the environment variable, it will automatically configure and use that particular app settings file. This is very helpful because development can have a different connection string to database as compared to preview, production, or staging. So it is already built in, and we will be adding our connection string in this file in the upcoming videos. So with that, we have a brief overview of all the files other than the pages folder and Program.cs. Let's continue in the next video. Next, we have Program.cs. This is the file that will be responsible for running the application. Once we open Program.cs, you can see we have a variable builder where the web application.createBuilder is passed with the built-in arguments. When you run with the .NET command, you can pass custom arguments here if you want. With that, it will configure the application and it will create the web application builder object. Now in the previous video, we saw that we can use dependency injection with .NET Core. When we want to register anything with our dependency injection container, we will be doing that right here. So let's say if we want to register our database or email or anything else, we will have to do that between the builder and before we call build on that builder object. So right here we are just adding one service to the container, which is builder.services.addRazorPages. We are adding the Razor pages to our container because we are building the website here with Razor pages, so we have to add that. If you were using MVC, then this would be add controllers with views. Now in the future videos, when we configure database in our project and we add that to dependency injection, we will be adding a new service here in our container or DbContext. If you are working with any version prior to .NET 6 or even some of the initial preview versions of .NET 6, then this file was divided into a separate startup.cs class file. And the services that we add to container were inside a method configure services, and everything from line 9 onwards was inside a configure method. So what we have on the top is we will be adding services to our container. Then we need to configure request pipeline, and that pipeline will be configured from the highlighted section. Now you might be wondering, what is this pipeline? The pipeline specifies how application should respond to a web request. When your application receives a request from the browser, the request goes back and forth through the pipeline. Let me switch to the presentation here. We have different browsers here, and then we have a pipeline. The pipeline specifies how application should respond to a request that is received. When your application receives a request from the browser, the request goes through the pipeline. In the pipeline, you can add items that you want. Pipeline is made up of different middlewares, and Razor Pages is a type of middleware itself. So if we want to build our website to be built with Razor Pages, we will have to add the map Razor Pages to our middleware. Other example could be authentication middleware, authorization middleware, and so on. What exactly happens is when your request will go through each of the middleware, it gets modified by them, and eventually it is passed to the next middleware. If that is the last middleware in the pipeline, the response is returned back to the server. Let's take a look at the few middlewares that we have in our application. Let me switch back to the code here, and you can see in the pipeline, first we are checking if it is development or not in the environment. If it is, then we are adding the use developer exception page that will show you user-friendly exceptions so that you can debug and solve them. But if it is not development, then we are just redirecting them to an error page. The next middleware is HTTPS redirection, and then we have a middleware to use our static files that are defined in www root folder. We also have a routing middleware, and we have authorization middleware. When we add authentication to our project, we will have to add a new middleware inside the Program.cs as well. Then we have app.map Razor pages. This will configure the routing of Razor pages and how the mapping will work in the application. Based on this routing, it will be able to map the URL request to the corresponding pages inside our pages folder. Then you should always keep in mind that order of pipeline is extremely important. The way you write middlewares in the pipeline, that is exactly how the request will be passed. So first routing will be done, then it checks for authorization, and so on. So in this scenario, if you want to use authentication to your pipeline, we have a middleware which is app.useAuthentication. But if you do this, then it won't work, because authentication middleware should always come before you authorize a user, because you only authorize a user that is authenticated. That is the basic fundamentals of authentication and authorization. So if you place the pipeline in some different order, that will break things. So with that brief overview of Program.cs class file, let's continue in the next video. One of the top-level considerations for the developer of a server-side web application framework is how to match the URLs to the resources on the server so that the correct one processes that request. The most straightforward approach is that you map the URL to the physical files on the disk, and this approach has been implemented by the ASP.NET team for Razor Page Framework. So the routing in ASP.NET Razor Pages maps URLs to the physical file on the disk. Now there are some rules on how Razor Page Framework matches the URLs to the files and how it can be customized to give different results if needed. The first rule is that Razor Pages needs a root folder. By default, the folder has been named Pages and its location is inside the root folder of the web application. Also in that folder, we will have a default document which will be index.cshtml. So let's go back to our application and see this in action. So the root folder is the pages folder that you can see here, and if we expand that, we have index.cshtml. Let me run the application here and see what happens. Inside here, we are navigated to the home page. The home page that loads here is the default index.cshtml inside the pages folder. If we click on privacy here, you can see the URL changes to privacy, and that page is present directly inside the pages folder. So the mapping of the URL is directly with the location inside the pages folder. Now if we stop the application and let's say we add a new folder here, I will call that as test, and let me move privacy inside test. Let's click OK here and let's run the application one more time. This time if you click on privacy, nothing happens. The reason is the URL that has been configured inside the master page, which is _layout. Let me show that. Here the ASP page is defined that you have to look for a page which is privacy directly inside the folder. But that does not exist because now we have moved that to a test folder. So if we go back, in order to navigate to the new location, it is simple. We just need to find out the exact path from the pages folder. So inside pages, we have a folder of test. Inside there, we have privacy. If we press enter, you can see it loads the privacy page correctly. So you can see routing has direct mapping on how the files are exactly stored inside the pages folder. Let me stop the application, close everything, and let me move the privacy page back to the pages folder. I will also delete the test folder that we added. Let's go back to our presentation, and here I have given some examples of how the mapping works. So if the URL is just www.domain.com, it will map to the pages folder and the default page index.cshtml. If the URL is domain.com/index, then it will map to pages/index.cshtml. And if it is domain.com/account, then by default it will first look inside the pages folder for a page with the name of account.cshtml, and if that does not find it, then it will look into the pages folder for an account folder, and in there it will see if there is index.cshtml, which is the default page. So routing in Razor Pages is pretty straightforward as compared to MVC routing, where we have models, views, and controllers. Here in Razor Pages, it is direct mapping to how the files are stored in the physical disk. So with that brief overview of routing, let's continue in the next video. In the last video, we saw how routing works in Razor pages. In this video, let me walk you through all of the default pages that we have. Inside our pages folder, we have one shared folder that has underscore layout, which is the default master page of the application. Here we have a header, we have a body where we will be rendering all of the other pages, so they will have a header as well as a footer. We will also have all the CSS and JavaScript that we want to include throughout all the pages. We can include them in the master page directly. So what happens is inside render body, we will actually render any code that we have inside the other pages. Like we have index and privacy pages, you can see we are displaying some text of welcome, and inside the privacy, we have the header here that we are displaying with privacy policy. So if we run the application again, let's examine what is the home page. So inside home page, you see we have the header, we have the footer, and whatever text we are displaying right here inside the index page is displayed between the header and footer as we have defined inside the underscore layout. So all of the code that we have here will actually go inside the render body right here. That's how master pages work. So that is our underscore layout page. Next we have underscore validation scripts partial. When a name starts with underscore, that is usually a partial view or a partial page. Partial pages are like user components. They cannot be accessed via a URL, but they are being called inside some other pages. So it's like a table that you want in 10 pages. You just add that table in a partial view, and then you call this partial view in all of these 10 files, and that table will automatically be populated. In this partial view, we just have two scripts for validation. So in future, in whichever page we want validation, we will be including this partial view. Also, it is a good habit to name your partial views with an underscore and inside the shared folder, so it's easy to find them when we have to. The next page that we have is underscore view imports. Here you can define the common namespace that you have in your website. So let's say in any of the pages, if you have to add the using statement many times, you can define them in this file, and that will be like a global declaration. So once it is declared here, it is automatically available in all the other files. One thing that you see here is we have added tag helpers. So because of that, we will be able to use the built-in tag helpers that the .NET Core team has provided. If we go to the shared folder underscore layout, and if we expand headers, for navigation, we are using the ASP page tag helpers. You can see we are not using the href tag here. To navigate within Razor pages, we have something called as ASP page. The tag helpers for ASP will start with ASP and then hyphen and then the name of the tag helper. We can obviously create custom tag helpers if we want, but the .NET Core team has provided all of the default tag helpers to make programming super simple. We will take a look at more tag helpers as we proceed with the course, but here we have added that globally in our application in view imports. That's why it will be available whenever we want to use them. The next file is viewstart.cshtml. In this file, we will define what is the master page of our application. You saw that underscore layout is being used as the master page, but that is because we have that defined here that underscore layout should be the master page. Now what you can do is globally you can have underscore layout as a master page, but on the individual Razor page, you can still use the same Razor syntax and define a new master page. If you want, you can define a different master page, but we will leave that with underscore layout. The next view or page that we have is an error page, and this is the page that is used to display the error messages when you face them in production application. Next, what we have is the index page right here where we are displaying the text. Now you might be wondering, if you are coming from web forms, that with the files there was a code behind file. If you are coming from an MVC background, you will be thinking, where is the controller? Where does the C# code goes? With Razor Pages, we have a .cs file, if you expand that, right here. Now this is not a code behind file, it is just the naming convention. Inside here, you will notice we have the index model, and it inherits or implements the page model. Here we have an onGet handler, and we will have an onPost handler that we can add if needed. So here what we have to do is, when this page is being called on get, if we want to do something, we will update that inside the onGet handlers. In MVC, we had action methods, but inside Razor Pages, we call them as handlers. So we have onGet handler and onPost handler. All of the code resides in these two pages itself. CSHTML has the page or UI code on what we have to display, and .cs will have the backend code where, if we want to retrieve some data and pass that to the view or page, we can do that. When we are working with Razor Pages, that will be @page directive at the top, and there will be a model that will be added here. This model, you can see it is index model. And if you go to the .cs HTML, that is the exact class name. It is index model. Based on that, it automatically binds both of this file, and it knows that this index.cs HTML.cs is the page model for the index Razor page. If this seems too much complicated, do not worry. When we start coding the application, everything will start making much more sense. And similar to index, we have a privacy page and a privacy page model. So those are all of the default pages that are available inside the pages root folder. With that, let me close all of these tabs, and let's take a look at Program.cs file in the next video. With that, let me close all of the tabs here, and let's continue in the next video. In this video, let's take a look at tag helpers. Tag helpers are brand new to ASP.NET Core. Microsoft looked at the success around libraries like Angular, React, and decided that implementing an Angular directive-like experience in the new ASP.NET was so important to the adoption of .NET Core that they decided to create tag helpers from ground up. Even though there are similarities between Angular directives and tag helpers, there is a major difference. Tag helpers are for server-side rendering, while the Angular.js directives are all about client-side rendering. If you have worked with older versions of .NET Core, we had something called as HTML helpers. They are still around, but tag helpers are being modern with the tag-like approach, so it's much user-friendly. Tag helpers are very focused around the HTML element and are much more natural to use as compared to HTML helpers. We will be working with tag helpers many times in the application, but to just give you a brief overview, you can see in the first tab here we have HTML helpers, and tag helpers simplifies all of them because we can use the existing label tag, and we will just add a tag helper ASP4, and we will bind that to a model. We have same tag helper right here as well. Then in the last example here, I am displaying tag helpers where previously we were using HTML.beginForm. And now within the same form tag, we have the tag helpers of where it should be posted. So you can see things are getting much more simpler when we are using tag helpers. That being said, if you are coming to .NET brand new and you have never worked with HTML helpers, this is even better. You do not have to worry about the old syntax and what is different. We will be working with tag helpers in the upcoming videos, but I just wanted to give you a brief snippet of what tag helpers are and how they look like when we are using the same tags. We just use the ASP hyphen and then the tag helper name. That being said, we will explore all of this in much more details in the upcoming videos. When you will be working with a .NET Core application, you will see the return type of action result. And it does not matter if you are using an MVC application or a Razor Page application. In both the cases, you can see we have iActionResult. In MVC, we are returning back view in this example, and in Razor Page, page handler, we are returning back to the page. But the return type is iActionResult. iActionResult is a generic type that implements all of the other return types. Now, if you want to be explicit about the return type in both of these cases, then that would look something like this. If the return type is view, you can write view result, but in Razor Pages, when we return back to page, you can write page result. So now, what is the advantage of iActionResult? So first, let's understand some theory. So ActionResult is a parent class for many of the derived classes that have associated helpers. The iActionResult return type is appropriate when multiple action results return type are possible in an action. Let's take a look at some of the helpers and action result. So first, let's take a look at what is there in Razor Pages. A Razor page can return content, file, not found, page, a partial result, and redirect to different pages. For all of them, we have return types like content result, file content result, not found result, page result, partial result, and so on. If we are working with an MVC application, we can return back views, partial views, we can redirect to action, return JSON, and so on. So if you are returning any one of these, then you can use the individual return types for result based on the helper method. But what if you were returning something like this? Right here in MVC, you can see we are returning if true. Let's imagine there was some condition here. Based on that, if that condition is true, you want to redirect to action, else you want to return to view. This time you cannot have two different return types. If you use view result here, return view is working, but redirect to action will throw error. Similarly, if you use redirect to action result, then redirect to action works, but return view will give you error. If you are working on Razor Pages and you have the same situation, if you use page result, then return page will work, but redirect to page will fail. And if you use redirect to page result, then return page will fail. So what is the solution to all of this? The solution is to use iActionResult in both the places. Because this is a parent class, so it does not care which of its implementation is being returned, it will be able to handle all of them. So that is a brief overview on how ActionResult will help us with the return type from action method in MVC application or page handlers in a Razor Page application. When we are working with any web project, we first need a database, and that is the heart of the application. In this case also, we will have to add a database, and we will be doing that using SQL Server. But for database, I will be using Entity Framework Core code first, and in that we create a model, and based on that model, we create a database table. So first we will have to create a model in our project. So we will create a new folder, call it as model. Inside there, we will create our first class file, which will be category. Inside this class, we will have to create all the properties for all the columns that we want in the table. Let's say we want 3 columns. We want name of the category, we want a display order, and the last one will actually be the most important one. All the tables require a primary key. So we will be adding an ID column, which will be identity column in SQL Server. What I mean by that is when we create any record, we do not have to pass that ID. It will automatically increment by 1 every time a new record is created, and that will be unique. So for all the 3 columns, we will have to create 3 properties. The first one should be the primary key. So for that, we will type prop here, which is a snippet to create properties inside Visual Studio. So we type prop and we press tab 2 times. It creates an integer by default. That's fine. We want to call that as ID. The next property that we want is name of the category, which will be a string, and we will call that as name. The last one will be an integer of display order. So with this, we have created a class which will be our table in the database, and it will have 3 properties or 3 columns. Now before we magically create the table, we need to do some more configuration. Let's take a look at that in the next video. We will be using Entity Framework Core to create the table and populate details inside there. But when we create a table, we need to tell Entity Framework Core that this column will be an identity column and it will be a primary key. Let's say we also want to add a validation that this name should be a required and not null property inside database. So how can we add all of those validations and requirements? We have many attributes that are available to define all of the requirements, and all of them are defined inside Data Annotations. So before the property here, we can give that an attribute inside a square bracket. The attribute to make this column a primary key is key itself. You will have to press Ctrl dot here to add the using statement, and you will press enter. Now by default, if a property name is ID, Entity Framework Core automatically makes it a primary key. So this is optional. But if your name was something different, like let's say you wanted to make display order a primary key, then you will have to explicitly say that. But if it is an ID and if you have not defined any primary key, then it will automatically set that as a primary key. That is good to know, but I always like to explicitly define so that when someone opens up that model, they can directly say which one is the primary key. Next, we want name to be a required, and for that we have an attribute which is required. That will make sure that name is a required property when the SQL statement is created to actually create this category table, which we will see in the upcoming videos. Right now, things are pretty simple. We created a class file, it has few properties, and we added some easy-looking data annotations for our requirement. How will we actually create this table and database? That is the main question. For that, we will have to do some configuration, like adding a connection string to our SQL Server, adding some NuGet packages so that we can use Entity Framework Core and SQL Server with our project. Don't be overwhelmed. Let's get started by adding the connection string in the next video. In this video, we have to add connection string. So before we do that, let me open up SQL Server Management Studio. Here, the first thing that you require is a server name. Now, many times a dot will work for localhost, but if that does not work, you can try localDB, MSSQL localDB. Whichever server name works for you where you can connect, that is the one that you will use. I'm going to use just a dot because that is working, and that's how I have configured SQL Server. I don't want the long one, so I'll just use the dot. Once you are able to connect here to SQL Server, we will go back to our project and we will add our connection string. Now, where exactly will we add that connection string? all of the settings like secrets that you have in the application, you should add that inside appsettings.json. If you examine, we also have development here. So if you have more versions like production, staging, preview, for each one of them, we might have different settings. So you can add different settings inside the individual file, and based on the environment name, it will automatically use the correct settings. For our local host, we will use appsettings.json. So inside appsettings.json, if you examine, we have some key value configuration. We have a block. Inside that, we have another block. And finally, we have key value settings. When we are working with connection string, we can directly create a key value pair right here. But connection string is something that is common across all the application. That's why .NET Core team has provided a special block that you can use for connection strings if you want. Using that will make things a little simple, but if you want to go with a custom block, that will also work. You will just have to put some extra effort to retrieve the connection string. We will use the default connection string block that is provided with .NET Core, and that is connection strings. Once you press enter there, you will notice the curly brackets. This means it is a block. In there, we can write our connection string. You can give that any key name that you want. I'm going to call this default connection. And after a colon in the double quotes, you will write your connection string. The first parameter here will be the server name. You will write equal to, and then whatever server you are able to connect in SQL Server, copy that and write that here. I'm using a dot, so that is what I will use. Then we will add a semicolon and we will add the database name. You can call your database whatever you want. I'm going to use Abby. Finally, we will have the security, which is trusted connection is equal to true. That's all that we need for connection string. The trusted connection is because I'm using Windows authentication to connect to my SQL Server. So with that, we have added connection string in our project. But we need to configure our DbContext so we can use this connection string and configure Entity Framework Core in our application. It might seem daunting in the beginning, but do not worry. Once we set everything up, it will all make sense. Let's continue in the next video. Now we have our connection string, we have our category model. How do we add this model to database? In order to do that, we will require Entity Framework Core in our project. So you will right-click on your project and you can select Manage NuGet Packages. Once you go there, we will have to install a package. Inside the browse, we will search for Entity Framework Core. We have the first package here, and I have enabled the include pre-release because right now .NET 6 is in preview. So we will install that package in our project. Now while we are here, I know we will be using SQL Server and that requires its own package as well. So make sure you search for SQL, and we have Microsoft.EntityFrameworkCore.SQL Server. Now when you install NuGet packages, if you are using the preview version or even if you are using the older version, always make sure that all the packages in a project must be of the same version. If you install one package in Preview 7 and other in Preview 6, it might not work. Or if you install one package in .NET 5 and other in .NET 6, it still might not work. So it has to be the same version, or else you might face issues later on. That being said, I will install both the NuGet packages so that we can add the configuration of Entity Framework Core in our project. Perfect, we will close the NuGet package manager, and now we need to create a DbContext so that we can interact with Entity Framework Core for database. So inside the project, we will right-click, add a new folder for data. Inside there, we will have to create our class file for accessing the DbContext. You can call this anything you want. I like to call that ApplicationDbContext. Now this file will implement the DbContext, or it will be like a data layer that will connect our application with the database. So it must implement the DbContext class inside the Entity Framework core. So we will add a colon here and we will write DbContext. Now you will see the red squiggly lines because it does not find or does not know what is this DbContext. If you press Ctrl dot here, you will see the using statement inside Microsoft.Entity Framework core. And DbContext is defined inside the Entity Framework core to access and manage the database. When we are creating a DbContext, we need to get the connection string as options. Then once you have configured this, inside this class, we will be creating dbSet for all the tables that we want in our database. So the first table that we want is the category model that we created. So in order to create that table, you will have to create a dbSet. So we will say public dbSet. We will write the model name, which is category. You'll have to press Ctrl dot to add the using statement. And then here, whatever name you give will be the name of the actual database. I will call it the same category, and we will have getter and setter. So here, if you named it category 1, your table name will be category 1. So this is actually the name of the table that you want inside your database. Our application DbContext looks good, but we need to do one thing. We have a DbContext in our project, and we have connection string inside our appsettings.json. We need to configure this DbContext to use our connection string. That way it will know how it can connect to the database. Let's see how we can do that in the next video. Now we need to add the connecting bridge between our DbContext and connection string. So we need to tell our application that, hey, you need to use this application DbContext to interact as a DbContext, and you have to use the SQL Server with connection string that is inside appsettings.json. So all of that mapping will be done inside Program.cs, where we are adding services to the container. The reason we are adding that as a service here is once we add it here, we can extract that and use it with dependency injection throughout the application. So we will be adding DbContext as a service in our application. Now previously in .NET 5, all of this was done inside startup.cs class file. But starting with .NET 6, they have combined both startup and Program.cs into one single file. So here we are adding all the services to the container, and then we are configuring the request pipeline. So now we no longer need multiple files. Everything is much cleaner. So in order to add service to our container, we will say builder.services, and the service that we want to add is DbContext. So we want to configure the DbContext, which expects a class name. So here we have to tell that which class in our application is implementing DbContext. That is ApplicationDbContext. Once you write that, you will press Ctrl dot to add the using statements for abbyweb.data. Then here we have to pass the options. So we'll say options here goes to, and we will say options dot. We have use SQL Server inside the Entity Framework core namespace. That way we are saying that for this DbContext for database, we want to use SQL Server. And inside here, we have to give the connection string. Now how can we extract our connection string from appsettings.json? I said before that connection string is a special block that is given by the .NET Core team. So that's why they have given a special method to access all the key values inside that special block. You can do that by using builder.configuration. They have given a method getConnectionString that will look for a key name inside appsettings.json. So inside connection strings, what is the key name we should look for? We should look for a key with the name of default connection, and we want its value. So we will copy default connection and paste that in the key name when we use getConnectionString. That will actually retrieve the connection string and configure our DbContext. Now here you can see with ApplicationDbContext, we are passing the options. So inside our class, where we have the ApplicationDbContext, we should retrieve that options and pass that to the base class of DbContext. So here we will have constructor using the snippet ctor tab. And with this class, we will receive DbContext options on ApplicationDbContext. We will call that as options, and all we want to do is pass that on to the base class of DbContext. Pretty simple and straightforward. But this line of code is very critical. If you do not do that, your connection will not work. Now right now it might seem that we are doing lots of magic things with setting up ApplicationDbContext, some code in Program.cs, and we are retrieving our connection string from the app settings. But this is very basic connection that you have to do with all .NET Core applications when you want to use and configure Entity Framework Core. So this can be treated as basic steps that you should remember and memorize. But what we are doing inside Program.cs, we are just adding items to the container so that we can extract and use with the help of dependency injection. As we proceed with the course, dependency injection will make much more sense, and you will see how easy it is by adding things to dependency injection to extract when we want to use them. So with that basic configuration, we are almost there. Next thing we have to do is we just need to create our database. We have all the configuration that is ready. Let's see how we can accomplish that in the next video. That all the configuration is done, let's finally create our database. Let me switch back to SQL Server. And here, if you examine the database, we do not have any ABI database. So we have connection string and everything in place. In order to make connection with Entity Framework and actually create SQL, we will be adding migrations. What migrations will do is it will see that inside ApplicationDbContext, we have a DB set on category, so it will write a script to actually generate SQL that will create this table. It is pretty fancy and everything is optimized. Let me show you how we can run migration first, and then it will make sense. There are two commands that you should remember. In order to run migration, we will go to Tools, NuGet Package Manager, and Package Manager console. Inside here, we will have to write a command to actually create migration. And that command is add migration, and we have to give our migration a meaningful name. So we will call this add category to DB. That is what we are doing. We added just category inside our application DbContext. So let me press enter and let me show you what error we get. We get the error the term add migration is not recognized. Now you remember we added NuGet packages of Entity Framework Core and SQL Server. One more NuGet package is needed for this. I want you to search this error and find out what is the NuGet package. Okay, I hope you were able to do that. If you just copy this, go to Google, paste that. The first one here, if you scroll down, there should be the package name right here. So these are small things that you will run into when you are developing, and you should always take Google as your first help station, because it is possible that someone else has faced this error and that will help you. So you will search for that NuGet package, make sure the version is same, and you will install that. Perfect, that is done. Let me close that. We will go to Package Manager console, and run the same command one more time. This time it will create a new folder of migration in your Solution Explorer and load the migrations. Great, you can see a new migration have been created and there is a new folder with the name of migration. So let's analyze on what we are doing inside the migration. You can see we have an up method and a down method. Down method is basically rolling back the changes that we are doing if something fails. So let's ignore that. Inside the up method, we have migration builder and we are saying that create a table with the name of category. In that table, we want columns. The first column will be ID column of type integer, nullable is false, and make sure that it is a SQL Server identity column. You can see with the key attribute, it is configuring everything for us. Then the next column name, it is saying that make sure that is not a nullable column. That is what we added as required. The last column is display order. That is also nullable false, but the reason behind that is it is of type integer. And then in the constraint, you can see we have a primary key on the ID column with the name of pk_category. So here you can see it is doing everything that we wanted. You won't be able to see the raw SQL that is being executed, but it is optimized. But in order to run this migration and see the table in database, we need to add one more command. So tools, NuGet package manager, console, and the command is update database. Let's press enter. What it does first is it will check at that connection string, does that database exist? If it does, then it will just push the migration that we added. If it does not, then it will create that database and then it will run the migration. So now the database should be created and in there we will have two tables. We have our category table, which will have the three columns that we created. Perfect. And we have a table which keeps track of all the migrations that have been applied. So let's examine the EF migrations history, and you can see it has the migration ID, which is name of the migration that you can see here, and the product version. That way Entity Framework code knows that this migration has already been applied, so next time when you run the command update database, it will not reapply this migration. Pretty smart to track everything that is being done with Entity Framework. So great, with that our database has been created successfully. Let me close everything here and let's continue from the next video. Now we have our category table that has been created inside the database. So what we want to do is we want to create a new page where we can display all the categories. When we are working with Razor pages, it will be inside the pages folder as compared to views in MVC. So inside pages, we have the home page, which is index.cshtml. We want to create pages for listing all the categories, creating category, editing category, and deleting category. Rather than cluttering everything in one place, we will create a new folder inside pages. I will name the folder as categories, and in there we will create a new Razor page. The first page that we want to create will be used to display a list of all the categories, so we can name that as index. We will select the Razor page empty here because we want to start with a clean and empty page rather than working with a template. So select empty and we will hit add button. Name of the Razor page, we will keep that as index.cshtml. Let's add that. As soon as you add that, you will notice two files were added. One is the CS file and we have the CS.html. The .cs file will be the file where we have page model for our index page. You can see the model that is being referenced here is inside Appy Web Pages, Categories Index Model, and this particular namespace will be the namespace that you see on top here. So that is how it is binding everything together and we have our class index model. Now we used Entity Framework Core to add migrations to create our category table, which was inside model, and our DbContext was ApplicationDbContext. Inside Program.cs, we registered that service in our container. Since we have registered this service, whenever we have to access database, we do not have to create a new object of ApplicationDbContext. What happens here is the service is already available in the container. So we just need to tell our container that, hey, I need to use the DbContext to access database, so give me an implementation of this class. How do you do that? That will be done using constructor inside the CS file. We need to create a read-only application DbContext, and we'll add the using statement. I will call that _db. Now we want an implementation of this class using dependency injection. That will be done inside constructor. So we'll type ctor, press tab twice. This is a snippet to create constructor quickly in Visual Studio. Now if you have registered anything inside the container and you want its implementation, you simply tell here the implementation that you want. So we will write that we want an implementation of application DbContext and give that to us in a variable with the name of db. We will assign our private variable, which is _db, the value of db. So now our _db will have an implementation that already connects to the database, and we can use that. Inside the onGet method, we need to retrieve list of all the categories. In order to retrieve that, we need to create a property that will hold all the category list. So on top here, we can create an enumerable on category, and let's call that categories. Next thing that we have to do is we need to populate this categories list. So this we need to populate from the database. So we'll say _db, and with Entity Framework Core, when you write dot here, it will display all of the tables or DB sets that we added. So if you scroll down here, you should see the category DB set that we added. So we want to retrieve _db.categories. This will retrieve all the list of categories. We did not have to write any fancy SQL like select star from categories table. We did not have to open a connection. We did not have to close connection. No cleanup was needed. Entity Framework Core takes care of everything, and we just access DbContext, and then on category, we have multiple methods to create, update, delete, and much more. But if you just say _db.category, it will automatically retrieve all of the categories and store that in this variable. Our get method looks good inside the index page model for categories. Now what I want to do is inside shared, we have _layout. We can navigate to two pages. We have index and privacy. Rather than privacy, I want to navigate inside the categories folder. We have the index page. Since we want to go in folder, we will not use the /. We can directly say categories and then /. What is the page name? That is index. So here we have to use the exact route that we have in folder structure. If you were using MVC, you have controllers and action method. But with Razor pages, everything is simple. The actual way in which the folders are organized will be the exact route. So routing is pretty simple in Razor pages. We will change the link here to display categories. And let me save this, run the application. Right now it is running things using the Abby web profile, but we will change that to IIS Express in just a second. But if we go back, we have the categories tab here, and you can see the URL in the bottom left. It displays the categories. Let's hit this button and see what happens. We see an index page here, but no data is displayed. We don't want to work with data right now. Let's go to our code behind here, and let me add a debugging point. Let's go back And let me just refresh the page. We hit our breakpoint. If I press F10, it will take us to the next line. And then if we examine what got populated in our categories, it will be empty because we do not have any records. So it yielded no result. Let me add a breakpoint on this line, remove the one before, and let me switch to SQL Server. We can keep our application running. Actually, I can hit the continue button to go back. Inside SQL Server, let me expand the database, tables. Let's directly edit the top 200 rows. Let me create a name, test, and display order too. So we have one record in our database now. If we go back to the application and hit categories one more time, it hits our breakpoint again. This time we should see one record that is being retrieved. And perfect, we see all the details populated. So with that, you can see we are successfully able to retrieve all of the records for categories from database. In the next video, let's work on displaying these categories inside the index page right here. Now that we have seen how to retrieve the categories inside the get handler, we need to actually display that in the Razor page. So if we go back to index.cs HTML, this is the index of categories and not of the main page. So inside the index of categories, we want to display all of the categories. If you have only worked with web forms and never worked with Razor pages, inside Razor pages you can have HTML code as well as C# code. So you can have if-else, you can create variables, assign them values, as well as HTML directly at one place. So let me add a div here, give it a class of container, and I will give it padding 3. These are just bootstrap classes to creating a container, and inside there we will create a row. So we will give it bootstrap class of row, padding top of 4. This will be one row on the complete screen. Now that one row we want to divide in two pieces. First, on the left hand side, I want to display a title. Since Bootstrap divides a row in 12 parts, if we want to divide those 12 parts into two pieces, for the left hand side we will have 6 pieces and right hand side we will have 6 pieces. So we will have div here, give it a class of column6 to combine the first 6 pieces in one single element. Here we will display an h2 heading and we will give it a bootstrap class of text primary. We want to display here the heading, which is category list. That looks good. Here we will have the later part, which is div of class column6, and we will add buttons inside this div later on. This looks good. Let me add some space, so 2 BR tags, and then we want to add a table to display our categories, so we will use a table tag. Inside this table, we will have a thead for header. Inside thead, we will have tr and th tags. This is just HTML tags that we are working with. Inside the first heading, we want to display the category name. And inside the next th, we want to display the display order. Now that is good for the heading. We want to have a body where we will be displaying the actual values. Now if we have 10 entries inside category, inside tbody, we will have a tr tag and td, just like we have th inside the heading. Here we want to display the actual value of category name. And then we will have another td, which will have value of display order. Now if we have 10 categories inside database, we want this tr to repeat 10 times because we want to display all the category name and display order. So if you were working with C#, you would be using for each loop. We will do the same right here. In order to use a C# code, we need the @ sign. And then we can just write for each statement. With for each, we need an object to iterate. So we will say variable obj in, and what we want to iterate on will be inside our index model. This index model represents what we have in the CS file. In order to show you, if you right click here and if you click go to definition, it takes us here, and you can see in here we have the variable for categories. So we can access these categories. Since it is an IEnumerable, we will iterate through that, because inside the get we are already populating that categories, so we should be good. So back to the UI, we want to iterate over that IEnumerable of category. To access this model that we have right here inside the lowercase m, we will have to use a keyword which is model, but this time the m will be capital. So whatever we have inside the smaller case model here, anywhere inside the view or page, if you want to access that, you will use the capital M model. So if you press model dot, you can see all the models that are available inside the CS file. So we want to iterate over the model.categories, and we will have a curly bracket here. So each categories inside the model.categories will have a temporary name of obj. This is how for each works. So for each one of the object, we want to display a tr tag, and we want to display the values. To display value, we need to access the obj variable right here. So again, we will use the @ obj dot, and we will see all the properties that are available. We want to select name from there. The next one that we have is display order. So we can say obj dot display order. We will add some width on both the td tags. With that in place, let me save this and run the application. If we go to our categories, we have the category list heading, and we have a table here, but I want to give it some bootstrap classes. So we can go back, and on the table tag right here, we can add class is equal to, I will add 3 bootstrap classes of table, table bordered, and table striped. Also, I will give it a style of width 100%. Now when we are making changes inside CSS or even anything inside the UI side of CS/HTML, once we save it, we can go back and actually refresh, and it should make those changes visible. But right now it is not working. We already added the Razor runtime compilation for this particular package. But the reason that is not working is right now there is a bug, and you have to manually add a statement. So for that, we will have to go to Program.cs, where it is adding the Razor pages. You also have to add a command here, add Razor runtime compilation. This should have been done automatically because we selected the Razor pages, but I believe since .NET 6 is in preview, they will fix this down the road. But if this is not present, add that, and let's run the project one more time. If you go to categories now, you will see a nice table. With this, you can see how we are able to display all of the categories inside our Razor page that we created. If you examine the URL here, it is only categories and not index, because index is there by default. If you write index manually and press enter, it will load the same page. Perfect. With that, let's continue in the next video. But before that, let me change the setting here to use IIS Express. That way we don't have the command prompt every time. Now our index page is working as expected for categories, and inside the CS file, we have the get handler. Before I proceed on the next task to create a category, let me switch back to database here, and we will write a query. So select top 1000, and let me just delete the record. So we'll delete the category that was present, and now there is no categories. And once we make that change, if we go back and run the application, perfect, everything is clean. Now I want to add a button here to create a category. We have not added that page right now, but we will do that. Let's go back to our index here, and we left a space inside the right-hand side of the category list. So we want an anchor tag. Now we want to go to a new page that we will create inside the categories folder with the name of create. So for that, there are tag helpers. The tag helpers that we want to use here is ASP page. If you were working with MVC, then you will use action and controllers. But with Razor pages, everything will be ASP page. We want to navigate to a new page with the name of create. Since this is inside the same folder of categories, we do not have to explicitly mention here the categories before create page. It will understand that by default. So we want to go to a new page of create, and we want to give it class of btn primary. Inside the anchor tag, we want to display create new category. Now the application is running and we enable the Razor runtime. So if you do F5, it should display the button. If you click here, nothing happens. This does not mean that your link is broken. Nothing is happening here because that page does not exist. If this was an MVC application, it will take you to a page not found, but with Razor pages, it is different. If the link is broken, it does not display a not found, it will just stay there. So in the next video, let's create the new Razor page to create a new category. Just like we added the index page to list all the categories, we need to add a new Razor page inside the categories folder to create category. So we will add new Razor page, empty, looks good. This time you have to call this as create. You can see here we are creating a Razor page and not a Razor view. Razor views are used in MVC application and they do not have a page model. We will create a Razor page and let's hit the add button. This time the model, you can see it is create model, and if you examine the .cs, you will see the class is create model. So that is how it links both of the file. Now right now we have the onGet handler. Inside the onGet handler of index, we were retrieving all of the categories to display inside the page. When we are creating a category, we do not have to populate any information. Inside the create page, we will just have an empty text box for user to enter the display order and name of the category, so that will be empty. Since we do not have to do anything inside the onGet, let's work on the view itself. Inside view, we will have a form in which user will enter name and display order, and they will hit the submit button. So we will have a form tag here. This will be of method post. Then we will add some bootstrap classes. We will add a div, give it a class of border, padding 3, margin top of 4. Inside there, I will add another div, give it a class of row, and padding bottom of 2. And I will just add a heading h2 that will display create category and an HR for a horizontal line. After this div, I will add another div, give it a class of margin bottom 3. And in here, we want to display the label, which is name, and then we want an input field of type text. I will copy this and paste it one more time. Next property that I want is display order, and type will be text. Of course, in HTML, you remember we give that some name like display order. The first one here, we can give it a name of category name. After that, we will have a button of type submit. And we can give it some bootstrap classes of btn primary, and a constant width of 150 pixels. Let's call this button as create. So perfect. Now we have a form to create our category. Let's run the project and take a look at that. So if we go on categories, and now if we select create new category, we see our new form. Let's continue with the form in the next video. Now in a typical web form, what happens is we have a name for this input field and display order. So when we post that, inside there we will try to extract that based on the name, and we will see what value was appended. But with Razor Pages, we have something special. We can bind this input text directly to a category model, and then we can use that model, or rather have those values available inside the post handler. So we will be binding this to a model. In order to bind a UI to a model, we have to create that property or model inside the model of the UI, which is createModel, that is inside the CS.html.cs. So just like inside index, we created an IEnumerable of category, and then we binded that right here to extract using model.categories. We can do something similar inside create.cshtml. We do not want an IEnumerable, we just want one single category. So we will create a category property, and we can access this property inside our UI right here. Inside the index.cshtml, we saw the tag helper ASP page that is used to redirect. Similarly, we have a tag helper that binds a property, and that is ASP4. Here we have to write the name inside our model. To extract that, we will need the @ sign. We will say model dot, and that is inside category. Inside category, this is for name. And with that, we also do not have to define any type or name. Everything will be done automatically, and all the bindings will be done. We will just add some Bootstrap classes for styling. Now this will create an input field. Similarly, we have something for label. So if we have a label here, and if we use ASP4, we can use @model here. But if you do not want to use the @model when you are using ASP4, it is smart enough to automatically bind the models. So you can directly say category if you want, and .name. That is pretty simple. But if you don't see that option, you can always use @model to access everything inside the model that is defined right here. So we are just adding a label here with the tag helper of category name. Let me copy these two lines and paste them for display order as well. We will just have to change the property name to display order. With that, let me save the changes, go back and refresh, and we see this error. Because we also modified the .cs file, we will actually have to rerun the project. If it was just the CS.html or the UI, then we do not have to rerun our project. So let's go to categories here, and if we hit create new categories, we have name and display order. Let me press F12 here and inspect the element. You can see on this element it automatically populates the ID and name, and you can see name is category.name. So it does all of the binding along with the type equals to text automatically. So you can see how life gets easy with tag helpers. Now once we enter any of the details here and we hit the submit button, we want to fetch those details inside the post handler. We only have a get handler right now. So let's add a post handler and continue from the next video. Now we need to create an onPost handler. By default, only get handlers are created. If you were working in an MVC environment, then you would create an onPost action method. But in Razor Pages, we create handlers. So creating handlers is simple. We will call public and then the return type. I want to make this an async method, so I will add async and task of iActionResult. iActionResult I'm using because I want to return to some page or redirect to a view. So that will be the return type, and we will call this onPost. Now when we have to name handlers, it will always start with the keyword on, and then we have the HTTP verb that this handler will do. This handler will support the post action method, so that's why we will call onPost handler. Now if you have multiple post handlers that you want in a Razor page, you can give this a handler name after the post. Like you can say onPost create, and then you can have onPost edit. that can be two post handlers. But right now, we just want to create one post handler to fetch the details that user entered and create that category inside the database. So here on post, we will receive a category object. Let me call that as category, and let's create that inside our database. In order to work with database, we need dependency injection with the application DbContext. So first, let me create an application DbContext. We will do control dot for the using statement, and I will require a constructor. So ctor, and I will retrieve that from dependency injection and assign that to my local variable. Then we want to create the category that we received right here. So for that, we will be using _db, and we have to define our model, which is category. On there, we have more methods. We have methods to add, remove, update, and much more. The first thing that we want to do is add. Now you can use this add, but we have added the async method. So let's use the async implementation, add async. In there, it expects a category entity that we have fetched with our onPost, so we will add that. Now when you are using async method, we will have to await that before we proceed further. When you write this one line, it is telling Entity Framework that hey, this is the category object that you have to add inside the category table. But it does not tell Entity Framework to go and do that right now. In order to tell that there is a different statement, we will say await _db dot we have save changes async. When you write the save changes async, at that time it gets all of the items that it has to change inside database and makes all of those changes. So if you forget to write save changes, it knows that it has to do that, but it will not save them to the database, and when it redirects or something, that will be lost. So always make sure to save the changes. Once the changes are saved, we want to return back to the index page. You see it displays redirect to action, but that is not valid in our application because we are using Razor pages. So with Razor pages, we have redirect to page, and we want to redirect to the index page. With that, let me save this, add a debugging point, and let me restart the application since we made changes to the code behind. Let's go to our categories here. We have create category. Let me enter test and a display order. Hit the create button. Now as soon as you do that, if you examine the category, you can see they are populated. Let's hit continue here. And great, that is created. So with this, we are able to create categories inside our application. But I want to show you one more thing. Let me close the application, and here we are fetching the category object and we are adding that. We already have a model here for category, so it is something that is redundant. To avoid that, .NET Core team has provided a special attribute which is bind property. When you use bind property, you no longer have to write it here. It automatically does the binding with the UI that we have on the screen, and that will be populated inside the same object. So then we can use this category and add that like this. This will make things much simpler. Let's run the application and try to create one more category. So let's create test1 this time. And great, it is working as expected. Now this is not needed right now, but I'd like to show you something else. Let's say you had 3 properties that you are binding here and inside the post. In that case, you will have to write bind property on each one of them. From .NET Core 2.1, they have added a special property that you can apply directly at the class level. That is bind properties. What that will do is all the properties that you have here and you're using inside the UI, it will bind all of them automatically so that you do not have to individually add bind property. So with that, if we run the application, our create should still work the same way. Even though we just have one category, it's good to know that we have that option available if needed. Let's try to create a new category, test2 here, and great, it's working. So with this, our create functionality is working as expected. Let's add some styling here and continue from the next video. I want to change the themes that we are using in our application. So if we go to Google and if we search for Bootswatch.com, this provides free themes for Bootstrap. If you scroll down, there are all the themes that are available. I will go with the Cyborg theme for this course. You can download the minified version or the Bootstrap.css. Let me download the Bootstrap.css. I will copy everything that we have open here. Let me minimize this and we'll stop the application. Let me add a new CSS right here. This will be style sheet. I will call this Bootswatch Cyborg. Let's add that and I will paste it here. Let me close this, and if you open site.css, they have added some different color for BT and primary. I will remove those two. That looks good. Now if we go to underscore layout, we can modify the Bootstrap reference that we have here to the new CSS. So inside the CSS folder, we have Bootswatch Cyborg. Let me scroll down where we are using the Bootstrap.js bundle. Let's go back here to bootstrap.com and let's scroll down. We have the CDN for JS with Popper. Let me copy this and we will paste that right here. This will make sure that we are using the latest one for our course. Lastly, if I go back with Bootstrap, we also have icons that are available to use. You can see there are quite a few icons that we can use in our application. To get started, let's go to the Install tab, and we have the CDN that we can copy. Let me paste that with the style sheets. So perfect. With that, we'll be able to use icons that are available with Bootstrap. Now that the CSS is updated, let's run the project and see what happens with the new theme. Things will be a little different. Perfect, that looks good, but I want to change the navigation here to be dark as well. So if you go back and if you examine the theme details, you will notice we have a dark navigation. Let's use that. In order to do that, we will go back to underscore layout. Rather than navbar light, this will be navbar dark and the BG will also be dark. Let's go back and refresh, and this looks much better. So you can see how easy it was to switch themes. Now I do not like the header and background both the same color, so if we go back to Bootswatch, let me find out some other theme. We can use this darkly theme and you can see the navigation is a little gray. Let me switch that. I will download the bootstrap.css, cut everything here. Let's go back to the application. We can remove that and paste the new code. If we go back and refresh here, great, this looks much better. Let me remove the two borders here. And in underscore layout, we will search for border. We will remove the border bottom. We have one more right here. And perfect. Let's go back and refresh. Great, the UI looks good. Inside the footer, I will say BG dark to get the little gray shade. Great, this looks much better. The only thing that is missing is our headings here are in black, so we'll have to go back there and remove the text dark to give them the white color. Let me save this and refresh, and great. Now the create category looks much better. Let me also align this on the right hand side. So we will go to our index, and where we have the button here, we can give it the class of TextEnd with Bootstrap 5. Great. Now while we are here, let's also use the icons of Bootstrap. So inside the icons, if we go to the top, let me search for pencil. We have this pencil square. We can copy this, go back to the create new category. Before that, let me add the icon and a space. With that, you can see adding icons is super easy. So with that, the design looks good. Now what I want to do is inside create category, if you try to hit create button, you will run into an exception. It says the SQL exception cannot insert null values in name. That is because the column doesn't allow nulls. Our entity framework core was smart enough in migrations to add the not null based on the required property. But here we need validations so that we do not see this ugly exception. Let's do that in the next video. Now we want to add validations on the create window. If we go back to our project and if we examine our model category, you can see for name we added a required validation. So we want to make sure that this basic validations that we have defined here should be applied when a user is inputting those values. Checking for those validations is super easy with .NET Core. First, let's take a look at server-side validation. So that will be done inside the .cs file when a user is actually creating the category. We are using a model here to insert inside the database, so we have something known as model state. That model state will get the bindings and its state, and in there we have an isValid flag. This will check if the model state dictionary is valid or not. Model state dictionary will have a key value pair for each entity that is there in our model. So inside category, it will have whether the name is valid or the display name is valid or not, because we are entering both of them inside the create UI. So let's examine model state.isValid. If that is valid, only then we want to create. If that is not valid, we want to return back to the page. And that is how it should be. But let's add a debugging point here and let's examine what actually happens. Let me restart the application because we made a change inside the page model. So with that, let's go to categories and try to create an empty category. We do not hit our breakpoint. That is because the breakpoint will only be hit if the model state is valid. Let me add a debugging point right there and hit the create button. If you hover on model state, you can examine all of the properties in there. The isValid is set to false, which means the model state is not valid. Now why is it not valid? That you can examine by going to the result view. You can see there are two properties that it is monitoring and both of them are not valid. The name is not valid because it is a required field, and the display order is also not valid because it is an integer field. If you enter null in there, that is not valid as well. Let me hit continue here, and this time you don't see the ugly screen because if the model state is not valid, we are returning back to the page. This time let me enter name and then hit create. The model state will still be not valid because of our display order. This time the error count is 1, and if you expand the result view, you can see name property is now valid, but the display order is invalid. So with that, we can easily check our model state, and only if the model state is valid, then we create, else we return back to the view. But that is not helpful. We should display an error message saying what actually is invalid so that user can fix that. Doing that is super simple with .NET Core. If you go to create.cshtml, we have a special tag helper to display the validation errors. So right after the property or wherever you want to display, we will have to add a span tag, and there is a tag helper ASP validation for. Here we have to write the name of model property that we want to bind with this validation. We want to check for validation category.name. So if there are any errors with category.name, that will be displayed in the span right here. And we will also add a class of text danger for the red color. Let me copy this and paste it for display order so we can monitor both of them. Once you save that, let me go back and refresh the page. Let me try to hit the create button. It hits our breakpoint and we get an error. Let me just stop the application. I get that from time to time, even though I did not edit anything while the project was running. So let me restart the application, and this time we should see the error messages. So let's hit the create button, and great. You can see it displays a default message. The name field is required and the value empty is invalid. So with that, you can see how easy it was to display validations from server side. Now the way you can tell this is server side is if you examine the tab here, every time we hit the button, it reloads. So it goes to the server and then it finds out that something is invalid, it returns back, and it displays the error message. With that, let's continue in the next video. These are the default validations that we have at the model level. But what if we want a custom validation? Let's say we want a validation that the name and display order cannot be same. How can we implement that custom validation and display that message right here? So let me close the application and we will have to implement that validation at the server side. And we can say if category.name is equal to category.displayOrder, we will have to convert that to a string. If these are the same, then we want to add an error message. So to manually add an error, we can access the model state, and in there we have a method addModelError. Now this method requires two parameters. First is a key name, and next is the error message. So you can name this key anything that you want. You can even keep that string.empty because we don't want to put anything in the key. But if you are adding more than one model errors, then you cannot have string.empty for both of them because this is a key value. So you can use distinct key name and then the error message. Let me say the display order cannot exactly match the name. So now we have added a custom error right here in our model state. As soon as you add this, the model state, even if it was valid before this execution, will now no longer be valid. And I will show that. But where will this error be displayed? Because if you go to create.cs HTML, we have the validation for individual properties that are displayed right here. But we have something where we can display the summary of all the validation. So let's say right here we want to do that, then that will be inside a div, and we have a tag helper ASP validation summary. We can keep that as all. In that case, it will display all the validation summary at the top as well as at the individual level. Let me save this and run the application. If you go to categories here and try to create an empty category, let me remove the debugger and continue. And great, you can see here we see the validation summary and same properties are displayed right here. Now this time let me enter test and a display order. I will actually add the debugging point again on post and let me hit the button. If you examine the model state right now, you will notice that it is valid. We will add a debugging point and let's continue. It seems like it went through, and of course it did because the name and display order were not the same. Let's keep them same again, continue, continue again. It is adding the model state error. Let me add another debugging point, hit continue, and if you examine this time it is not valid because we added a custom model error based on our requirement. So if we remove all debugging point and hit continue, we see the custom error that display order cannot exactly match the name. So this is how you can add custom validations. Now I want to show you one more thing. You can see we have used the tag helper to display label. If we go back, we have the label for display order and name. It is using the exact same name as property. But what if we want to display something else? What if we want to display a space between display order? Because inside the error messages also, it displays the same format. To do that, we have lots of data annotations that are available to help things. Let me go back to category and stop the application. Here we have the required data annotation. Similarly, we have a data annotation which is display, and there we can provide a name of whatever we want it to display. So let's call it display space order. Once you do that, if you save and run the application, now wherever it has to display the name of the property, it will use this display attribute and whatever name we have given. So if you go to categories, create new category, you see the space between display order, and if you write same thing, you have that in the custom validations. And my bad, this will not change because we are adding the custom string. So if you want that, you can always change that here. I thought for a second it was retrieved from the property name, but that's not the case. But you can see we can change the display attribute to display label wherever it is being displayed. Next, we also have custom data annotations other than required display and key. If you go back to the Microsoft documentation, you can see all of the annotations that are available, and there's quite a few of them. We have one here that is range that checks if the specified number is between a range of values. If you scroll up, we have the min length, phone number, key attribute, that is the one that we used, and we should have a display as well. Let's see how we can use the range attribute when we have the display order. Let's say we want to make sure that display order should always be between 1 and 100. So here we can use the range attribute, and it expects two parameters. One is the minimum value and maximum will be 100. Along with that, if you want to specify what error message should be displayed if that condition is not true, you can customize that if you do not like the default message. So we will display our custom error message, and let's see this in action. If we try to hit the create button, we have the invalid, but if we enter, let's say 222, hit create, now we see our custom error message. So there are lots of data annotations that are available that you can check out on the documentation. But we saw the use of display as well as range data annotation. With that, let's continue from the next video. The validations that we have seen so far are server-side validation. On each request, it goes back to the server and then displays the validation. What if you want to use client-side validation? The custom validations like name and display order should not be same will be server-side. In order to validate things on client-side with the .NET Core application, inside the shared folder, we have a script which is validation scripts partial. Here we have the jQuery to do some validations on the client side, but this is not included by default in all the pages. So in pages where you want to do client-side validation, all you have to do is include this partial view. Partial views are meant for that purpose itself. They are created to be used inside some other view. So let's go to our create, and how do we add a partial view? Partial views are like user components if you come from the traditional .NET application. Since inside there we only have script tags, so if you have to add any script tag inside your view, you have to create a new section. So we will create a section for scripts, and inside there we will use the razor code. We want to add a partial view. So for that we have a partial tag helper, and we have name there where we need to write the exact name. Make sure you do not make any spelling mistake there, or else it won't work. So with that, our partial view is added. If this partial view did not have just script, it had some code, then you could have added that within your HTML like this. But since it is scripts, we will add that inside the section of scripts. If you have any JavaScript code that you want, that will also be added within this section itself. So on Razor page, you can add a section to handle all of the JavaScript. Once you do that, you do not need any other changes. We just need to run the application and see client-side validation in action. So let's go to categories here and let's hit the create button. This time the page will not reload. You can see all the validations are done on the client side. If you go to the page model and add a debugging point, when you hit create, it does not hit the debugging point anymore. But the custom validation that we have here is still done on server side. So if we add 1 and 1, hit create button, it goes to the on post and then it displays the validation. So if you want to be fancy, you can do that validation in JavaScript as well, but by default the .NET Core does not display the custom validations on client side, and that also makes sense. Now before I end this video, what if we want to display this validation inside the name? So basically, when we are doing this, you can see we have validation that name field is required. I want to display that validation for the name property. Doing that is super simple. We stop the application and the key here, we will have to change that to be category.name. Let's run this and see what happens. Let's hit continue, and great. You can see now we are binding that directly. So if you want to bind some custom model state errors to a property, you just need to provide that key name and it will automatically do the binding. So with that, let me remove the debugging point and let's continue from the next video. That our create category is working as expected, let's work on editing a category. So for that, we will have to go back to the categories page. And when we click here, the navigation doesn't seem to work. Let me go to underscore layout. Where we have the navigation here, we will have to add a forward slash. Let me save that, refresh, and perfect. That's much better. We will always need a forward slash and then the complete path because we have the pages as the root directory. So after that, how do you navigate to index? So after pages, change the directory to categories. In there, we have index. Now in the index page, we want to add two buttons of edit and delete. Let me go back while the application is running. Inside index, we have two th tags. I will add another th here, and inside the table row, we will add a td. Inside this td, we want to add two links. The first one should take you to an ASP page using tag helpers. It should take us to edit page, and we will give some bootstrap classes btn, btn primary, and margin x of 2. Inside the anchor tag, we want to display an icon to edit. So we can go back, set the bootstrap icons. We used pencil. We can copy that and paste it for edit. Next, we want a link for delete. So let me copy this, paste it one more time for delete. That will be btn danger. Let's go back. We will search for a trash icon. Let's copy that and paste it here. If we scroll up, we are using pencil for create new, so let me change that to something else, like a plus sign. So we have the plus square, let's use that. Let me save this, go back to our application, and refresh. Perfect, so we have all the icons. Let me go back and add some styling. So right inside the TD, let me add a div, give it a class of width 75%, btn group and row, and we will close that. Let's refresh, and this looks much better. So if we go back, we will have to add two pages, one for edit and one for delete. Now when we are editing any of the category here, we need to know that which category user selected. So we need to pass the ID when a user clicks on any of these buttons. We have a special tag helper for that. When a user clicks this link, we want to pass something to the route. So we have ASP route, and then after hyphen, we can give it any name. Let's call that as ID. And then the value that we have to pass is inside this obj, so we'll use the razor at obj.id. That will pass a variable with the name of ID to the get handler of this particular page. So let's create that page and work on that in the next video. Now that we are passing the ASP route ID with the actual category ID to this edit page, let's create that page. If you want, you can create a new page inside categories. What if we want to copy this create and reuse that? The reason to reuse is because the view or the UI will be exactly the same. It's just rather than displaying an empty page, we will have to display all of the items that are loaded. So let me copy this create and paste it one more time. Then to edit, we will have to stop the application. Let's press F2 and change the name to edit. If we expand this, we have edit.cshtml. You think that is sufficient, right? But once you make this change, let's try to run our application. We will have some error messages. What is the reason behind that? I want you guys to pause the video and try to see if you can find out what is the reason. We just copied the create and we modified the name to edit, but it is failing. I hope you guys were able to figure out the actual reason. Let's take a look at edit.cshtml and create.cshtml. If I toggle between them, you can see that the create model is being used for both of the pages. That cannot happen. Each page will have its own unique model. So what actually happened is when we copied and pasted inside the CSHTML, it is using the same model for both create and edit. We have to change the name of this model. You can name it anything that you want. I'll call this Bruggen model. We will have that constructor, and inside edit, we will have to use the same. With that, if you run the application, everything will work as expected. So that was the main culprit over there. But we should name this as meaningful as possible. So let's call this as edit model, and we will change that in all the places. When you were copying and pasting things inside MVC, this was not an issue because it would rename the class and everything would work when you are working with controller. With Vue, they don't have a tight bind because there is no .cs in MVC. But when you work with Razor pages, if you are copying and pasting, make sure to change the model in both the page model as well as the UI page. So with that, we have added the Edit Razor page. Now one thing that will be different inside Edit Razor page is inside the onCat, we will actually have to retrieve the category and we will have to pass that to the view or the UI that we have here. Inside the view, it is already binding that to category.name and display order, so we just need to populate the category object right here. In order to find that, we will be receiving ID in the parameters here, so let's write that. As I said before, inside the index.cshtml, I am passing the route with the name of ID. So inside edit.cshtml.cs, we can fetch that directly here, and based on that ID, we will retrieve the category from database. So _db.category. Now we want to find a category based on ID. That could be done in many ways. The first one here is find. In find, if you write ID, it will automatically find that and assign the category. Find will work on primary key of the table. So the ID that you pass here must be the primary key of category table, and that is the case. Because of that, it will automatically find that record and assign that to our category. Now, similar to find, I have few more methods that I want to show you. The next method that we have is first.default. We have both first as well as first.default. What will happen with first is we need a lambda expression here, and we will say u.id is equal to the id that is passed here. Here we are saying that from category table, find me the first record that matches the id, which is equal to the id that we are passing here. Straightforward. Now the difference between first and first.default is that if it does not find any record with that id, first will throw an exception. First.default will just return null. That is the difference between first and first.default. Another way of finding that is using single and single.default. You can use single when you expect only one entity to be returned, because in single, if more than one entities are returned, that will throw an exception as well. Whereas in first, if more than one entities are returned, it will just ignore everything else and send you the first one. So single is more strict when it comes to returning values. Inside single.default, if nothing is found, it will return null. Inside single, that will throw exception. So similar to first and default. And then here again, you will need lambda expression. So u.id is equal to the id. Last but not the least is not the favorite approach when we are working with one entity. Here you will have a where condition, and you will say where u goes to u.id is equal to id. So it will retrieve all of the records where the id matches. With this statement, it can return 10 records, it can return 20 records, wherever the id matches. So on that, once you retrieve that, you will have to call first.default. These are just multiple ways of doing the same thing. I prefer either find or first.default. I'll just comment this out so that you can play around with them. But that will retrieve the category and assign that to our category object. Then inside the post action method, what we are doing is we are adding the category. We do not add the category. This time we just want to update. So on dbSet of category, we have an update method, and since that is not async, we will have to remove the await keyword. With that, it will automatically update the properties that are different based on the primary key. So you can see how easy it is to update any of the category. Let's run our application and give this a try. Now before I run this, we'll just go back to the edit view. I'll have to change this create to edit, and where we have create button, we will just have to change the text to update, because it is anyways submitting back, so the form on post handler will be triggered automatically. Let's go back to our application and let's try to update a category. Let's hit update. Now you might think here that update is working, but actually it's not. Let's try to update this category and change the display order to 5. You can see it is not actually updating, it is creating a new record with the updated entities. And why is that? I want you guys to pause the video and analyze on why this is happening. You guys were able to figure out the reason edit is not working, but it is rather creating a new object. Let me show you how I debug to find out what is the issue. Let's try to edit this, change the display order to 6 here, and we will switch back to the application where we have the edit.cshtml.cs. We will add a debugging point on the onPost. Let's go back and hit the update button. This time, let me examine the category, and you will notice that ID is 0. Now, if you pass an object to update with an ID of 0, Entity Framework Core will think that this is a new object, I need to create that. Because of that, it is creating a new category rather than updating. But the main question here is why is ID 0? Now the reason ID is 0 is inside edit.cshtml we have binded the category name and display order, but we have not binded the ID. So that's why there is no ID field right here. So if you want to do that, you can have an input field which is hidden, and we will use the ASP_for tag helper. This will go to category.id. With that hidden field, when the form is posted, it will have the ID populated. Let's hit continue here. We get this error. We'll have to stop and restart the application. And let me also remove the debugging point. Let's go back and try to edit any of the category now. So we have this 5. We will try to edit that and change that to 6. And perfect. This time it did not create a new category. So these are very small things that you have to debug in the application. Best way is to add a debugging point and analyze what is the value. That will give you the exact idea of why that is not working. So with that, our edit functionality is also working as expected. Now for your assignment, I want you to implement the delete functionality. When you hit delete, it should open up the same page as edit. It should say delete category, and this field should not be editable, so they should be disabled, and you will have the delete button here. But before you do that, I want to add a button here to go back to the category list. Also inside create, let me add that button. So let me go back to the project. We will open up the create. We will add an anchor tag with ASP page of index, some bootstrap classes, and within the anchor tag, we will have back to list. Let me also copy this and we will paste that inside edit. Let me save them, go back and refresh, and perfect, we have back to list that is working as expected. Now here we just wrote the page of index. So what happens is within the same directory, it will try to find the page with the name of index. We already have that, so it automatically takes us back there. But you might be thinking that what if I want to redirect to some other page? Let's say we want to redirect to this index page, which is the root page of the application. That is super simple. Before index, you will add double dot and forward slash, so then it will take you back to one level, and inside that folder, it will try to find the index page. Let me show that. We will save this inside edit. Let's go there, back to list. We get back to the home page and not the category list page. We will roll back, bring things back to normal. Perfect. If you have to route to some other folder inside pages, how to navigate there? So perfect. Now in the next video, you have to implement the delete functionality of deleting a category. So good luck with that, and I'll show you that in the next video. I hope you guys were able to implement the delete functionality. We will switch back to our application. First, we will open up the index page here, and we need to pass the ID to our delete. So we will paste that here, and then we can stop the application, copy what we have for edit, and paste it one more time. We will rename that to delete, and we need to change the page model. Make sure you're working on delete here. We'll change this to delete model, copy that, go back to the CSHTML, and we will rename there as well. Now when we are deleting on get, we will have to find the category that we have to delete, but inside post, we can do something different. We will have the ID that will be populated inside the category, so we will have to find the category object from database. We do not need this if condition. If the model state is valid, we can create a variable category from db is equal to _db.category.find. Find that based on category.id. So that will find the complete category object and populate it right here. Next, we can check here if category from db is not null. In that case, we will say _db.category, And we have the remove method, which expects a category entity. It does not expect an ID, it expects a category entity, so we will pass category from DB to be deleted. We will remove this and we will paste the save async inside the if condition. If the model state is valid, we redirect back to index, else we go back to the page. So the page model looks good. Let's make changes to the view. This will be delete category. Everything will be disabled. We do not need validations. Let me add the disabled field. And we have the hidden ID. That looks good. I'll change this to danger and delete. Perfect. Let's run the application and try this out. Let's go to our categories and try to delete test and 3. As soon as we try to delete, we get this validation. The validation summary, we should remove that, but something is not right. The reason behind that is if we go back, it is returning back to the page. So the model state is not valid. Now obviously the model state will not be valid because it will not have the name and display order since they are disabled. So we do not want to add model state there because we are just finding the ID. Based on that, we are retrieving that from database and deleting that. We will move the redirect inside the if condition. With that, we will have to restart our project. Model state does not get populated for disabled field. So that is something that you should keep in mind. Let's delete and perfect. You can see delete is also working as expected. Now with that, create, update and delete are working for our category. Let's continue in the next video. I want to display an alert on the index page that shows that what functionality has been done. And those alerts should go away if you refresh the page. So they should not stay on the page once they have been displayed. For such special functionality, we have something called as TempData with .NET Core. TempData has one main feature. It remains for only one request, and if you refresh the page, it goes away. So that will work perfectly when we have to display alert notification. So let's see how we can add something to our TempData. Let's go back to the application and let's work with create. Let's open up the .cs file. Inside the on post, before we redirect, we want to set something in TempData. So we have TempData that we will write here, and we need a key name. You can call this anything that you want. I will call that success because that is the success message. So inside the key of success, we want to store a string which is category created successfully. We can copy this TempData and we can add that in delete as well. Before we redirect, we can say category deleted successfully. Inside edit, before we redirect, we can say category updated successfully. So we are setting our TempData on create, edit and delete. Now if you notice, once we create them, it is redirecting to the index page in all the places. Inside delete also, that goes to the index page. So what we will do is on index.cshtml, inside the view or the UI side, we need to retrieve that TempData and see if there is any string value inside there. So right here on top of the page, we will use razor syntax and we'll have the if statement. We will say if TempData, you will have to use the exact key name. If you use something else, it won't work. So if TempData of success is not null, what we want to do is an h2 tag. I want to display the value. So in order to get the value from TempData, it is pretty straightforward. We just write TempData success. Let me save all of that and we will have to restart our application. This time, let's try to create a category. As soon as we create, you see we get a notification in h2 tag, and if you refresh the page, that goes away. So that is perfect. This way it only stays there for one request. If you delete a category, you can see we have our alert, which is category deleted successfully. So this is great news and everything is working as expected. Now rather than displaying a string on top, it's best if we use some fancy JavaScript code. Let's do that in the next video. Right now we are just displaying an h2 tag, but we can add something fancy in our project, and that is Toastr.js notification. If you go to the Toastr.js Git repo, you will have a demo where we can see how Toastr notifications look, and these are much fancy. If we go back to the GitHub, we have the CSS and JS files. Let me copy the CSS. Let's go back to our application. Inside the underscore layout, we will add that at the top here. Link rel is equal to style sheet, and href we will paste the URL. Next, what we have is the JS. So let me copy the JS file, and then JS we do not want to include in underscore layout here. Let me do that directly in index.cshtml where we have TempData. One way I showed you how to use script is at the end we can use the script section. Another way is right here. We can use the script tag, and within here we will say type is equal to text JavaScript, and we can use some custom JS right here. Before that, we just want to include a script, so we'll say script src is equal to, let me paste the URL. Now when we are working with Toastr at the same place, we will also need jQuery. So if you go to underscore layout, we have jQuery script right here that is included with our project. We can go back to the index and paste that right here. We will remove the h2 element here, and perfect. Let's clean this up. Now within the script tag, we want to call Toastr, and on there we have method of success. Let me go back and show that. We will have the use at someplace. You see we have toastr.success. We can copy that and paste it here, and inside the parameters we want to pass the temp data. That should be done inside single quotes. Now we need to access the razor code, so we will use the @ temp data of success. That in place, let me save this, go back, and let me refresh the application. Let's try to edit a category here. Now we see the fancy Toastr notification. If we delete a category, everything is working as expected, but now we have a fancy notification. So similar to success, you can also implement an if block here. That will be for error temp data, and if you set something inside error, we will display that. This will be error. So that way we can use Toastr with our project. We have added alerts to our project, and if we go back to the application, this is some code that is common for alerts. If you want to display alerts in other pages, you will have to copy this code every time. And what if in future you change something here? Then you will have to go to all the files and update the same code. That is a bad approach, and for that particular scenarios, we have partial views. We can move this code inside a partial view, and then we can directly call that partial view here. That way in future, if you have to change something, you will only change that in one places, and wherever that partial view is called, you don't have to change anything in those files. So for that, we will stop the application. Partial views we will always add inside the shared folder. We will right click, add new razor page. We will go with the razor page empty, and so far we have been selecting razor page, but that creates a page with a page model. Partial views do not have a page model that you can see inside underscore layout and the validation scripts partial. So that will be a razor view. Razor view does not have a page model. And naming of partial view I always do with an underscore. That way, by taking a look at the name itself, I can say that that is a partial view. Name we want to give here is notification. Let's add this razor view. You can see there is no page model with the partial views. Now here it says for enabling MVC projects, just ignore that. We will be using this as a partial view in the razor page, and that is completely normal. Let's go back to our index and let me cut the code for Toastr, go back to notification, and we will paste it right here. We will save this, then we will go back to our index, and we need to call our partial view with the name of underscore notification. Now when you have to use notification in some other page, you will just have to add this one line of code, and also in future when you have to change something, you will just change that directly in partial view, and you don't have to make that change across all the other files. Let's run the project and make sure everything is still working the same. Let's go to our categories, and we have an error. I believe there is some spelling mistake. I forgot an I here. Let me save that and refresh. Let's try to delete this time. And perfect. Since these are magic strings, make sure that the name is exactly the same, or you will run into the error messages like we saw. So this is great, but what if in your functionality you wanted this partial view to be across all of the pages in your application? If that is the requirement indeed, then it doesn't make sense to add this one line in all the pages. The alternative for that is we can cut that partial tag from here and add it inside the underscore layout directly, because this is rendered in all the pages. So here, just before render body, we can paste the partial tag and run the project. If we try the categories one more time, it should work as expected. Perfect. But you should be careful with this approach because you are adding a piece of code that will be present in all the pages of your application. If that is something that your requirement demands, then for sure, go ahead and do that. But do not add a bulky code here that is not used. It will just increase your application overhead. So with that, all of our CRUD functionalities are working as expected. Now we have seen how we can add pages to our application and how to modify everything else so far. Let me show you one more thing here. Let me create a new folder inside Pages and call this category temp. In there, if we right-click, add razor pages, you can see we have options here to directly create razor pages using Entity Framework for all the CRUD operation. What exactly will this do? Let me show that. If you hit the Add button, first thing that you have to do is you have to select a model. It will create all the pages for CRUD operations, which stands for create, read, update, and delete. So we have to select a model there, and we need to select the DbContext because that way it can access the database and modify everything for the CRUD operations. Once you add those two, this won't be a partial view. We want to use our master page underscore layout, so we will set that as blank, and let's add this. This will take a while to scaffold everything, and then it will add all the pages inside the category temp folder. Now that it's done, if you expand that, you can see it has added pages for create, delete, details, edit, and index, everything by itself. Let's run the application and take a look at them. In order to navigate there, we have to do the manual navigation. So here, the name of the folder is category temp. We can write index, but if we don't, it will find that by default. And great, you can see there is the index page and we had one category. It is automatically displaying that. We can create a new category here. That's working. If we hit create new, it also has validations. We have go back here, We can edit the category. That's working. We can view the details, and we can delete the category. So all of the functionalities of a basic CRUD application are done for us if we go with that route. But I did not want to go with that because I wanted to teach you how to write all of this on your own. But if you examine the code here, it is doing the same things that we have done, nothing fancy. So that's just something for you guys to play around. Let me remove that because I do not want multiple code. So with that, our project is done, and in the next video, let me show you how we can deploy this to Azure. Now the final task is to deploy our application to Azure. So for that, you will have to create an account on portal.azure.com. I already have an account. If you are signing up for the first time, you will get $200 of free credit that you can use. The first thing that we have to do in here is we need to create a SQL server and a database inside that. So we can create or search for SQL databases, and let's hit the Add button. Usually I like creating everything from Visual Studio, but SQL Server I like to create here. That way I can easily see all the configuration. You will select the subscription that you have, and in there we can create a resource group. I will call this resource group as .NET Mastery _course. And then let's enter a database name. We will call that .NET Mastery _DB. We do not have a server, so let's create a server. The server name will be unique, so I will use .NET Mastery Server, and then we need an admin login. We cannot use admin here, that won't work, so I will just use admin SQL. For password, you can use something secure, select your location, and hit OK. Now next option is we want to use Elastic Pool. We will say no there, and in the server location that's not available. So let me select some other location, East US 2, and let's hit OK. Then you need to select the compute plus storage. We will select configure database there, and I will use the lowest option, which is basic here, and that is 5 USD per month. Let's apply. I do not want to pay more for the subscription, so I'm going with the lowest option. The redundancy backup, that is perfectly fine with me. Let me hit Review plus Create. We will hit Create here, and it will take a while to configure our database and set everything up. And perfect, our database has been created. If we click Go to Resource, it will take us to SQL database. Now one thing that you will have to do is if you want to access this database from your local SQL server, you will have to select the Set Firewall Settings and add your client IP. That will enable your client IP, and you can access the database from SQL Server. Let's hit the Save button to add your client IP there. Once that is done, let's go back to SQL Server, and we need to connect to that server. So we will hit OK here, go back to the resource, and we have connection string. Let me copy the server name here, go back and paste it, and we will use SQL Server authentication. We have admin SQL, and the password. Let's press connect. Great, we are able to connect to our SQL Server. So with that in place, let's continue from the next video. Let me close the other tabs here. Now that we have created our database in Azure, we can go back to Visual Studio and let's publish our application. We will have to create an app service plan and we will have to publish. We can do that directly from Visual Studio as well. So here we will right-click on Project and select Publish. We will be selecting Azure and hit Next here. And then for now, we will be publishing to Windows App Service. Let's select Next. Then you will have to log in to the account where you want to publish. Once you sign in with the account, you will select the subscription name here on the top, and we will have to create an app service instance. I will call that as Abby Web, so the final website, or rather the temporary website, will be abbyweb.azurewebsites.net. It is a free domain that is provided by Azure. So we have subscription name. Next is the resource group. You can create a new resource group, but I already have one of .NET Mastery _course. That is what I will use. Resource group are basically tags that you can add to combine things under one umbrella. Nothing fancy, just like a folder structure. Next, we have the hosting plan. By default, an S1 tier hosting plan is selected, but I want to use the free hosting plan that Azure provides, so we will select that and press OK. Let's hit the Create button to create our app service. That creates our app service, and we will hit the Finish button. The final step that we have is we need to configure our SQL database. So you can see in the service dependencies, we can hit Configure here, and we can add an Azure SQL database. It is already displaying the database that we created on our account, so we will select that and hit the Next button. Now the connection string name inside our application, if you remember, inside the connection strings, that was default connection. We just need to write our user ID, which is admin SQL, and the password. Once you do that, it automatically populates that in the connection string. Then we do not want to save connection strings in app settings or Key Vault right now, but we can just copy the connection string. Let me open up a notepad and paste it there. Let's go back and hit the Finish button. Now that we have the connection string, let me click on any one of the settings that we have here. Inside the database, we need to paste the connection string. So let's expand that, and our connection string is valid. We will just select the Use this connection string at runtime. Then inside the Entity Framework migration, right now there are no migrations that have been applied. We already have the migrations in the folder, so we can select Apply this migrations on Publish, and that will create the tables inside the database. Now right now we are working with .NET 6 and it is not available in the app service. So for that we will change the deployment mode to self-contained, and that should work. With that change, let me save this and publish our application. You can see the site name I said before will be abbyweb.azurewebsites.net, and this is a free subdomain that is provided by Azure. It is retrying the add operation, but that is failing. Inside the logs here, you can see we have issue with the client IP. Let me copy this error, paste that in Notepad. I believe we added the IP. We will copy this, go back to Azure, in Overview, set firewall. We will add a new client IP. Let's save that. That is the IP from the server. With that change, let me publish it one more time, and it should work. Once the deployment is complete, it will automatically load the website URL in a browser. It is loading our website. Let's take a look. And great, you can see everything is working. There will be a new categories table with no category right now. We can add categories. We have our alerts, and we can edit, update, and delete. So everything is working as expected, and our website is live on Azure. Congratulations on completing the course. With this course, you have a basic foundation on Razor Pages and how to perform CRUD operations using Entity Framework Core. This is just getting started with Razor Pages in .NET Core. There are many more topics that I cover in my advanced course. Let me just give you some highlights of the topics that I cover in that course. The project that we have built so far, we will divide that project in an n-tier architecture where we will have a separate data access layer. In that data access layer, we will be using repository pattern and unit of work to access our database. We have already seen TempData in action, so we will use that, and we will see how we can add API controllers with our Razor Pages project. That way we can use the APIs that we build in data tables, and we will see suite alerts as well as rich text editor. These are just some basic functionalities in a typical application. Also, in any real-world application, we have authentication and authorization. So for that, we will scaffold the built-in identity Razor class library that the .NET team provides. With authentication using identity class library, we will also see roles and authorization in action. Once we add authentication and authorization to our project, then we will use Stripe for payment collection, and we will also see how to issue refunds using Stripe APIs. We also have sessions in .NET Core, so we will see how to configure our application and send emails using SMTP and SendGrid. I will also show how to use Facebook for social login. We also have some advanced concepts like view component and how to see database with the initial data using a DB initializer class. Once we cover all of these advanced topics, we will deploy our application to Azure and we will see how everything comes together. So this will be a pretty lengthy course and we will go into building a real-world project with real requirements. So if you want, you can check out this course and other courses on .NET Mastery, and if you like this video, please like and subscribe to the channel. So I hope to see you guys in some other course. Till then, happy coding!